Unmuted. Good. Yeah, sorry for this. So hello, everyone. My name is Milan Docinovsky. I'm affiliated with the Institute of Applied Informatics at the University of Leipzig. Together with my colleague Jan Forberg, we will drive you through the DBpedia technology stack, and there are two topics that we would like to focus within this tutorial. The first one is to get you familiar with the DBpedia technology stack, and in particular with the DBpedia Databus Platform, the Databus collections technology, and the last topic is on replication of the DBpedia infrastructure. So during the tutorial, Jan will explain how you can replicate this technology and how you can use the technology to build Docker applications. There are 3 sessions, each dedicated to a particular topic. The first one is on the Databus platform, the second session is on the Databus collections, and the third is on the Dockerized DBpedia applications. If you have any questions, feel free to post the questions in the chat or raise a hand here. Ideally, you post the questions in the Slack channel. If you're not there, please join. Yeah, please mute yourself and turn off the video if you have turned on to save some bandwidth. And as you might know, the tutorial will be recorded and it will be later made available online on YouTube, so that you can then follow it at any time if you want, or share with your colleagues. And also the slides will be shared, so you can follow the tutorial later at your own pace. So I'm about to give the word to my colleague Jan, so he can start with the first session. Okay, Jan. Hello, Jan.
Yes, hi. Now I have the action. I share your screen, right? Okay.
Please, the floor is yours.
Thank you. Wrong slide. Here we go. All right, so you can hear this and see this, right?
Yes, perfect.
All right, perfect. So yeah, hi, I'm Jan Forberg, and I'm gonna now tackle the first of the sessions, which is the Databus Platform, and in general the DBpedia technology stack. So the DBpedia technology stack is a range of applications and services that are based on the DBpedia databus as the central part of the stack, and it really facilitates the process of deploying your own DBpedia infrastructure and also to build your own applications on top of the DBpedia stack. So here you can see at the core the databus, which is a data management and publishing platform. On top of that, there's an aggregation and retrieval feature, which is called the Databus Collections. It is sort of a way to query data from the databus and plug it into your applications. And then on top of that aggregation feature, we have some already pre-built applications that are used to deploy your own chapter, like the Dockerized DBpedia with Virtuoso Endpoint, a lookup for entity retrieval, and Spotlight for text annotation. Here's the rough structure of the databus core. On the right, you can see that the data is not actually published on the databus itself. Only metadata is published there, and the data is hosted by the publishers. So if I want to deploy something on the databus, I will have to care about the data hosting myself, and I only tell the databus where my data is located. On the left, you can see the Databus Collections as this aggregation and retrieval feature, where you query then on that metadata on the databus. the databus then fetches, the databus collections then fetches that decentralized data, and you can optionally route it through download and conversion module, where you could, for example, convert the decentralized data that you just downloaded into another format or another compression, and then you plug it into your applications and services. The data on the databus is structured whatever, and it's basically similar to Maven. In Maven, you have publishers that aggregate their software into groups. Then the software pieces are artifacts, and the software is updated over time. So you will have multiple versions of that software, and you can go there to fetch an old version or always fetch the latest version. And the databus does the same thing and tries to mimic this with data. Usually you have people working on data sets and they are improving over time, so you will have multiple versions, and the databus gives a structure for this process. The most important thing, and that's why the boxes are so big, are the artifacts. So artifacts are basically data entities, so a specific topic that is being described by that data. For example, the user Mike could want to tell the world something about animals and creates a group animals, and then he has data on cats and data on dogs and creates an artifact for that. And now users know where to find Mike's data about cats, and he can then upload different versions while he improves his data sets over time. And that's the retrieval is made possible by using a URI pattern that mimics that structure. So you will have the databus base URI, and then in the URI, the publisher, the group, the artifact, and finally the version. An example here would be the mapping-based objects from the DBpedia extraction, which is in the mappings group, because there are many other mapping-based artifacts, and a specific version. Right. Before I go to the next session, I will show you the databus itself. And there is a website that shows you if you type in these identifiers into your browser, you will go to an HTML view, which is basically a fancy view with a faceted browser on that metadata that has been uploaded by, in this case, DBpedia. But there's also a version of the databus that is called the raw databus. You can type in the databus base URI and attach a raw dot in the beginning, and this will basically cut out all the HTML and only show you what's most important, and that is the hierarchical structure of the databus. So for example, here I can go for DBpedia. Now I have all the groups of DBpedia listed. Can go to the mappings. Here are all the artifacts in the mappings group, the different versions, and finally all the files that are associated with this version. These files, though, are only, these are not hosted on the databus itself. This is a redirect to the location where the actual file is being downloaded. However, you can use this structure with wget to pull data from the databus, which is one way to get data from the databus. All right, so I'll continue with the second part of the tutorial, which is how to actually upload your data to the databus. There is a really extensive manual on how to use the Databus Maven plugin, which is currently the way to upload your data to the databus. You can find the resources that I'm using today in this tutorial here in this Git repository. And here's a short list of what's required to upload your data. First of all, you will need Maven 3.3.9 or higher. You will need a web ID and a databus account. So you can go to databus.dbpedia.org and create an account there. If you want to know how to create your own web ID, there's also a tutorial. I think it's listed here on the next slide. Yes, I'll come to that in a moment. And also this tutorial covers on how to create a PKCS12 certificate that is linked to your web ID. Then you will need your data, obviously, and you need a server to host your data. Yeah, so here's the link to so you can create your own web ID. Creating a Databus account is quite simple. It's basically just a registering process on the website. And thirdly, you have to link both accounts, your web ID and your Databus account, and you can do that by. So here is my web ID document. To take this URI, go to the Databus, log in, go to your, oops, this expired. And here is a field in your account page for your web ID URI. So sign into the Databus, go to your account page, and insert the web ID URI into this field here. Yeah. All right. So I will go to my console now to show you the things that are listed here on the slides in real time. And the screenshots here on the slides differ in namings because these names have been used for uploads in previous tutorials. And I will switch to another name in the data project. So here I have data project. This you can find this in the Stack tutorial resources in the GitHub repository that was in the slides earlier, and in the folder Databus upload, there's already a preset data project. So here you can see that this is a Maven project with POM XMLs, and we will go ahead and look at the POM XML that is at the root of the project. Oh, it's not. Right. Okay. Yeah, here we go. All right. So this is a quite complicated setup at first, but once it's set up, it's really easy to redeploy things in an automized way. If this is all too complex, we totally agreed with internal And first of all, usually the setup is made with Docker Compose, and Docker Compose consists of multiple Docker containers. And the Docker containers are usually an application container, the download container, and then several helper containers that is being used by the application container. The download container exists so you don't have to rewrite this download process and this file conversion process from the Databus over and over again in your applications. You simply run this Docker container. It will pull the data into a local folder, and via Docker volumes, you can share the access to this folder between containers, and your application container can then access that folder once the data has been pulled. The download container creates a download LCK file in that folder, and the application container can check for this download LCK, this download lock. And once that lock is gone, you can be sure that the download has been completed. You can find the Dockerized DBpedia container, which is one of the parts of the DBpedia technology stack, under this GitHub repository and the Virtuoso Sparkle endpoint quick start. And this Dockerized structure, this Docker Compose, consists of the download container that does the downloading, as explained before, a helper container which is a triple store, and then the actual application container that cares about installing the DBpedia plugin on the Virtuoso, and also to load the data that has been downloaded by the download container to the triple store. There is also the DBpedia lookup that has been rewritten to work with the DBpedia databus. Again, the download container is being used to pull the data, and once the data has been downloaded, the lookup container can then build an index on that data and run a Lucene search that can then be used to retrieve entities from your linked data. This does not only work for the DBpedia releases, so the DBpedia lookup is not specifically only for DBpedia data, but can be used on any RDF data. For example, the search on the Databus website is being built on Databus dumps. So the Databus takes its content and then publishes the content again on the Databus, so making a bit of databusception, and then the DBpedia lookup container then picks up that dump and is able to provide a search over the Databus. And then we have the DBpedia Spotlight. That works in a bit of in another way, not using the download container this time, but pulling the data from the Databus with a fixed query, as the Spotlight really only works with a specific with this pre-trained Spotlight model that is published on the Databus as well, but only really works with this type of data. So here it made sense to specify a fixed querying for a specific file on the Databus with this application that is being pulled on startup, and then run the application. Here's some details on the Spotlight. I think I will skip that for now, and some screenshots on the Spotlight, because I want to show you how this deployment works, and it is indeed quite simple. So you can visit this GitHub repository with the Sparkle endpoint quick start, and it's called quick start for a reason, because you can basically copy and paste this to your console, and this will take care of everything. What it does is it will clone the repository, move to the folder, then set some environment variables and run Docker Compose up, which will start the download container, the loader container, and the triple store. The loader container and the download container at some point will turn itself off when they are finished with their job, and the only thing that keeps running is the triple store with the DBpedia plugin installed and your data loaded to the triple store. The environment variables that you have to set, you can set more by configuring everything that is inside of this environment a variable file here. So there's a couple of environment variables, some admin password that you can set. The environment variables that you should set is your collection URI. So you can, in this case, we use the latest core collection, but you can use your own data or your own data collections, and of course the password, and change that to something more complex than password. Right. So now that okay, maybe I should have started with a smaller collection. So now you basically have to trust me that after this is finished, your resources will be available here under port 8890 Sparkly, and that you can query your data. I think we are. I will keep this running and maybe check on it later when we're done, maybe with questions. Then I think the results should be visible. All right. So I see that I went through this rather fast, and there's probably some questions. So I will give back to Milan for some closing words, and then I think we have time to answer questions.
Thanks, Jan. Very nice. Yeah, let's maybe cover some questions before I wrap up the tutorial and we close the meeting. So, are there any questions from the audience? Yeah, feel free to paste your questions in the chat or in our Slack channel. Let's see if there are any questions. There is a question from Oliver. He writes, now that you have a publication framework for DBpedia data, how do you decide how to split, organize what was once a single data set?
Yeah, I mean, the DBpedia release has previously already been split up in different files. So, for example, you could go to the download server and get the labels of resources, for example, and the new release and managing platform. In the case of DBpedia, kind of mimics that. So there's a DBpedia user, and then there you will. So there's some more artifacts that were added, but basically one file is now an artifact. So you will find the labels all aggregated under one artifact, and you'll find all the abstracts and aggregated under one artifact. But yeah, it's really up to the publisher to experiment and find a structure that makes sense for their data project. I think if it's a really huge project like DBpedia, there's maybe some improvements that can be made, and I think it's more simple for smaller data sets to find the right structure. Yeah, definitely. Well, we can have a look at how DBpedia is organizing the data. So there are a few core data sets behind DBpedia, and this is basically the DBpedia account on the databus. And we have the generic group of data, we have the mappings group of data, we have the Wikidata group of data, and we have the text group of data. And usually these, how you group and how you name the groupings depends on, in the context of DBpedia, it depends on the extraction framework. So here within the generic group, there are the data sets or the data artifacts which are provided by the
generic part of the framework. Then we have the mappings. These are based on the mappings which are created manually at the mappings DBpedia org server. Then we have the text group, which is basically providing the data extracted from every Wikipedia article. And then we have the Wikidata. Those are the information mapped to Wikidata. And within those groups, for example, looking at the mappings, we have another set of data artifacts, such as the mapping-based objects, cleaned, uncleaned. Then we have the instant types there, and looking at the instant types, and then you move to the different versions that have been published of this particular data artifact.
And so there's a lot of artifacts and being published by DBpedia now, but we selected all the artifacts that were in the old DBpedia releases and added some more, and added this to the latest core collection. So the latest core collection is basically this holds the same data and more data and improved data as the old DBpedia datasets, like the 2016-10 and the other versions that use the old publishing platform. So yes. Yeah, for retrieval, it's the latest core collection that is important.
There is another question from Capsolo. This is the guy with this username in the Slack channel. He's asking, can you feed the quick start application with a list of RDF file URLs or a directory of RDF files instead of providing the databus collection URI?
Well, you can go to the Docker Compose and simply delete the download container. What the loader container of the quick start is the important element in this Docker Compose setup, and the important container. And that container will start up, check the folder where the data is supposed to be, which is also configured in the Docker Compose. If there's a download lock in there, which would be created by the download container, and if it's not there, it will simply start its job and starts running to load data to the Virtuoso. So if you remove the download container and make sure that there's no download lock in your downloads folder, and you put these files into the data folder by hand, then this works. So the loader container will simply start loading data to the Virtuoso. You cannot provide a list of file URLs. You would have to download or write some script to download the files to the data, to a specific folder directly, and then tell the loader container where those files are located. And then this works without databus collections. Or you can use both. You can already put files in your folder and then use a collection with a databus a download container on top. No.
Okay, good, thanks. There is also another question from Robbie Morrison in the Slack channel. Can Databus manage license constraints to ensure that the return data is in compliance? I think this feature is not yet supported, Jan.
So you can specify a license, obviously, with the upload, but I'm not sure how that is covered or if that is implemented. We would have to come back to this question later on.
Yeah, I think this question relates to the retrieval of data, so that the user can specify what data or constraints on the license, and based on this, the databus would need to consider this when returning the data. But I'm not really sure this is.
I see Sebastian typing, so he might have an answer for that.
Yeah. Okay, any other questions?
I think something that I haven't addressed so much is how to use this framework or use this stack in your own applications. Much not for some developers, this might already be really clear, but yeah, this for some applications it's really important to work with data that is being uploaded over time and improved over time. So, for example, a visualization application that is should update itself without user intervention, and these Sparky queries and the collections are a static query or a static collection identifier that points to dynamic data. And this is where it enables developers to query something static and retrieve dynamic results and to update their applications.
Okay, yeah, thanks, Jan. I see Oliver Russell is typing in the chat. In the meantime, we can cover some questions that that popped up, and yeah, I basically answered those in the chat. But I think it's also interesting to loudly comment on this. So there was a comment from Oliver Russell on the Marvin tool, which is basically a tool that is used by the DBpedia core team to publish data on the databus, to basically to generate to run the extraction framework and publish data on the databus. So it's kind of a tool that simplifies the whole process. It's the code behind it is open, so you can grab it and run and generate, or run the extraction framework and generate the same data that you find on the databus, but run it locally. There is link, so you can find the link also for the Marvin tool also in the chat. There was also a follow-up question on the mappings, if mappings can be disabled or if new mappings can be added. So basically, there is the mappings.dbpedia.org server, which is maintaining the mappings, and there you can create mappings or edit existing mappings, so that when you run the extraction framework, those mappings are retrieved and considered when doing a new release, for example, of DBpedia. And also there was a question on the configuration, related to the configuration of the extraction. And yeah, you can do the configuration on your own. If you look in the Marvin config repository, there is the extraction configuration folder, and within this folder you can find the configuration documents. For example, you can specify what extractors should be considered for the extraction itself. You can also configure the languages that you want to extract. So if you are interested in a particular language, then you can specify this language in this configuration document, or you can enable, disable particular extractor as well. Okay, I guess there are no other questions.
And
yeah,
there was a question about bug tracking. There's a link on the Databus website at the top to report issues. And for Databus issues, we use GitHub. And so if you find anything that is not working, please report the issues here. And also there was a specific question about GitHub for data issues. And yeah, I think it's also, so I think if you go to the right here on the artifact pages, you can also find an option to report errors and create issues for the specific data sets.
Yeah, what's also very powerful, or let's say useful, behind this Databus platform is that the data artifacts, they are linked to the code that is responsible for generation of this artifact. So you can directly go to the code and investigate why something is wrong in the output. You can also report errors. You can edit documentation. You can discuss this data on the forum. So it's basically everything kind of centralized and with relevant pointers to particular locations where you can follow up and work with this artifact. Do you want to add something more, Jan, on this, or?
No.
Okay. Yeah, then let me wrap up the tutorial. Okay, so yeah, so in summary, these two topics have been discussed during the tutorial. One of those was the Databus Platform, where Jan explained how you can upload data on the databus and how you can work with the databus collections so that you can then pre-select particular data sets for your collections and then consider the use of those collections in your applications or workflows. And the second major topic was on consuming data, DBpedia through the databus and developing Dockerized DBpedia applications. And there were these two particular examples which use this approach. One is the lookup application, and the other one is the Spotlight named entity recognition and linking tool.
Sorry to jump in there. We didn't show this lookup in Spotlight here in particular, but it is basically the same workflow as the Dockerized DBpedia. So you go to the GitHub repository, copy paste some bash script, and start the Docker container. It's as simple as that. So exactly, it didn't make much sense to show it here.
Yeah, there is also some configuration possibilities to configure Spotlight, for example, for particular languages. Lookup you can configure with your own data as well. So it's yeah. Okay, so before we end, I would like to thank all the association members and all the supporters of the DBpedia. If you would like to join the association and become a member, feel free to contact us. You can find more information at dbpedia.org/membership and check what are the options there and how you can apply to join the DBpedia Association and become a member. Let me also say a few words on the events that have been organized by the DBpedia in 2020 and the planned events for 2021. So there were already 2 tutorials on the DBpedia technology stack, one in July, another one in September, and this one in December actually. Then there was a hackathon that we organized which lasted for 2 weeks. It was in autumn between September 21st and October 5th. with a follow-up conference on October 6th on knowledge graphs in action, DBpedia linked geodata and geoinformation integration conference, which was quite successful, I would say. For 2021, we plan another series of events. We would definitely want to update and organize another tutorial. The dates are not yet known for the online version, but we plan, this is still not confirmed, but most probably there will be on-site tutorial, the DBpedia Stack tutorial, which we will organize as a half-day tutorial at the Language, Data and Knowledge Conference, which will take place on June 14th in Zaragoza, Spain. So we will plan to collocate the DBpedia tutorial with the LDK conference. Also, early in 2021, we plan to organize a DBpedia chapter plenary call. So if you want to join the developments and contribute to a particular DBpedia chapter, you're welcome. We will announce this very soon. In May, we plan to organize a knowledge graph conference, which will probably go online. And last but not least, we plan to organize a DBpedia day, a DBpedia community meeting, which will be collocated with the Semantics Conference, which is planned for September 6th until 9th in Amsterdam, Netherlands. It might happen that we organize additional events and to stay with the most recent information, to receive the most recent information, please visit the dbpedia.org/events website, where all those events are published with a description on how you can join and participate in those events. Here on this slide, you can find a list of links, useful links, which are relevant to DBpedia. There is the forum, the Slack workspace, the mappings DBpedia server. Then we have all the GitHub repositories behind DBpedia, the Databus Platform. We are also present on Twitter, and also there is this link which points to the DBpedia events website, where you can get information about the next events. So thank you all for joining, and talk to you in another occasion.